All right, my name is Francis Bitonti. I'm founding director of Bitonti Studio. What I'm here to talk about today is how we make things. I'm talking about the way we make things and the tools that we use. We've always been in this position where we're forced to deal with a linear progression in how we make tools. We've made tools out of wood that we use to make stone tools, or we'll make one tool that will make one particular kind of object or one particular kind of shape, and then we'll need, if we want to build a whole assembly, we need lots of different tools. It's very hard to break this cycle. The kind of future that we're trying to prepare ourselves for in the studio is a future in which software is a tool for forming matter. We're trying to break that chain. We're trying to give that tool development a virtual space to exist in and let it be subject to all the things we've enjoyed about digital computing. And this is going to change really the way we approach not only design, but the way we approach our supply chains, the way we approach manufacturing, the way we think about materials, the way we think about interfacing with customers, the kinds of experiences you can offer customers both in an online environment and a physical retail environment. And we're going to talk about all of these things, but what I want to talk about first is form. And I started my career as an architect, and I was very interested in form. And just as the Eames and all the great modernist designers found a language of efficiency and production to deal with a very particular production model, we're trying to do the same for 3D printing. How do you find efficient form with a fabrication technology that allows for infinite complexity, infinite material variation, complex differentiation of materials? We can do things like this now, right? This is called a cellular automata. This is an algorithm. A machine made this image. Not a machine, a computer. Well, it's a machine. A machine made this image. It's made by a set of simple rules. The rules look like this. So imagine a grid. You have a bunch of boxes on a grid, and not one grid, any box on that grid knows anything other than what its neighbors are doing. And it goes through permutations line by line until you see an image like you just saw in front of you emerge. And that image is complex. It's got all the things we'd expect from a great work of art. There's structures coming together. There are recognizable structures. There's structures falling apart, coming back into shape. It's really beautiful. This is a similar thing. This is an algorithm used to simulate flocking of birds. We're using it to design garments, design dresses, to think about the way form relates to the human body. And we're doing that because we're working with a material understanding that's purely digital, right? We don't need to worry about tooling. We don't need to really worry about any of the things we've had to worry about before, but what we are trying to do is we're trying to produce not only complexity, but variation. So this is the same algorithm, right? So we see a lot of customizers where you can make things fit better or have these, sort of kind of marginal advancements in tailoring. But if you go to something like this and you design with intelligent systems rather than just these kind of parametric CAD models, this is the same algorithm. It looks completely different. It's responding to the body in a different way. It's the same production technology and material that will make this piece, but it's a completely different object. You see it responds to the hips and the different points of curvature on the body completely different, whereas the other one held very close to the figure. And we can then translate that data into different objects and garments. And these are all procedurally generated garments. And we've done these for educational purposes, so they're actually all available to the public and free online. So form has changed. The kinds of interfaces to customize form are completely wide open now. And what about materials? So the thing to remember with 3D printing is you have micron level resolution in most cases over material. Not only single material construction, but multi-material construction. This is an MRI, right? It's a digital image of a physical material construct. And what we're doing is you're representing that material through a set of different pixel values and thresholds. There's black pixels, which would represent denser matter, less dense matter. White pixels would be things like bone, incredibly dense matter. And everything in between is a gradient of those, right? So we have precedent for thinking about material construction as images. And we can use those to then construct 3D geometry. So why can't we do the reverse? So this is a research project we did with Stratasys a few years ago to try to reverse engineer this process of digital imaging. Could we generate digital imaging to create materials with that same level of complexity and intricacy? We started off by wondering if we could make a textile. Could we make a textile that was both transparent and opaque, flexible, but also hard? And could it be continuously transforming from one to the other like we see in the MRI, right? There's no hard lines. This is not an assembly. All that material differentiation is grown within micron by micron. And what we ended up feeding the printer was something like this, which is very similar to that MRI. If you'll notice here, you're seeing lots of different shades of pink, but really all that's there are 16 micron boxes of red and white. And all that differentiation you see is a combination of different permutations of microstructures that are giving us different material properties. It's all being algorithmically generated. None of it's anticipated. It's just growing in a digital environment and being pushed to a printer. And the result of that is something like this. And if you zoom in, not only is it incredibly formally complex and intricate, but also you'll notice there's no hard lines between materials. Those yellowish ones are clear acrylic. The black ones are a rubber like latex. And those material differences are more obvious in these images here. And these material differentiations can be generated in things like a web browser, right? Like this doesn't really need any very sophisticated equipment. And as the technology becomes more democratic, this will probably be a desktop technology. We can also apply this to make continuous color gradients. These are some shoes that we've worked together with Adobe on, made in the same fashion. So materials are different, form is different. Factory is a completely different environment. This is what we're most well known for. Most people think it's a couture dress. It's not. It was made in a factory in Long Island City, Queens. It was not made in a couture house. It has 3,000 unique moving parts. It has 12,000 crystals on it, black hematite crystals, and it's sewn into a corset. She gets in and out of it like any other dress. It's flexible, laces up in the back. This is how the material comes out of the printer, fully assembled, articulated, flexible. It's tumbled to be soft. And it's made just for her body in 3 dimensions. We didn't make any flat patterns for this dress. And you can see here, she moves in it. Our goal was to create something she could sit down in. I mean, until this point, most 3D printed fashion had been very heavy, like armor. And I want to just close on one of our last projects, which we're trying to really think more about the whole supply chain, what it's like to live with a product. If a product becomes purely digital, what happens to heritage? We've been talking a lot today about luxury objects being timeless. Is timelessness still possible, or is it an application? If it's infinitely variable and customizable, do you own that digital asset forever? And is the consumer in a role of co-creation? Traditionally, with factories, you aggregate resources at a single point. This is what our factory looks like. We have 76 locations. We partnered with a company called 3D Hubs. We set up individualized manufacturing facilities so that everything can be made locally and on demand. We keep no inventory. We launched a collection of housewares last year in beta. We've since redeveloped this quite a bit. We'll be relaunching in the spring. The idea was that you'd have a customizable product in the browser, digital files generated in the cloud, sent to your local manufacturer based on your zip code, and then that would be delivered directly to you, all done in a bioplastic on desktop grade technology. No post-processing required. I'm going to leave you with some images of that collection. And we're currently developing ceramic versions of these now. All right, thank you very much for your time.